Hey, Geo students, we are going to have some fun. Our end of the semester project, the Rube Goldberg Machine. Yes, you guys get to create a Rube Goldberg Machine. And what is that? What is an RGM? Well, basically, it is a machine, is a contraption that does something that is really simple in an incredibly complex manner. So there are many videos and things out there. We're going to be sharing some with you, but I wanted to make sure you had a chance to see what it is that we're going to be doing. We're going to be talking about this paper a lot, or this document a lot, in our synchronous class this week. We're going to go over it very carefully, but this is a nice little introduction for you. Um, Basically, what you're going to do is find a way to take a face mask off of a peg and move it 1 meter horizontally. Remember, horizontally is flat. It's got to go from one side to the other, not up and down. It's got to go 1 meter, at least 1 meter horizontally. So what you're going to do is create a machine that has 10 steps. Each of those are going to be connected to one another, and you're going to start it off and you're going to use energy transformations. What do you mean by that, Fredericks? Well, you're going to create something that has potential energy, maybe gravitational potential energy, where you've raised it up and it falls down and it starts getting the energy of movement, kinetic energy. And then that kinetic energy is going to hit something and going to start it over again. You might have elastic. Maybe you have a string that snaps, or a rubber band that gets let loose, or you might have a ball that falls, or you could have a bunch of different things. You're going to see lots of examples the next couple of weeks. But one thing I would like you to try is I want you to start getting comfortable with the difference between potential energy and kinetic energy. So this is what I would love for you to take a look at. I want you guys to spend a little bit of time on the PHET, PHET simulations. You can see here, you're going to just type into the chat bar or in a new tab into the URL window, PHET Energy Skate Park. And then you're going to hit return. And it's going to take you to the University of Colorado. And I want you to go to the Energy Skate Park Basics. And that's going to open up a simulation that will let you practice and learn and get comfortable with kinetic energy and the transformation of kinetic into potential and vice versa. Actually, it's more potential into kinetic, but you'll see what I'm talking about here. So first thing I want you to do is go ahead and click on all of these so you can get an idea of how this all works. Maybe we won't do speed. Yeah, we'll do speed. We're going to have about a medium kind of a mass, but here's the thing. We want to bring, oh, wait. I am looking for where my friction is. I don't see the friction right. Oh, that's because I didn't click on the right one. Let's go back and do the friction one instead. My apologies. All right, it's loading and we're going to do friction. And now we'll click on that. Here's your friction. So we have mass. We can go small, medium, or large. And we're going to do 0 friction for now. Click on all of the different meters and graphs. And I want you to let go. And I want you to watch what happens. So first of all, there's no friction slowing the skater down. And he or she has total energy that changes back and forth between potential, which is blue at the top. Kinetic is at its highest point at the bottom when it's going fastest, and then it changes again. and watch what happens. But notice that the total energy never changes. It just transfers back and forth. And then we want to add friction. We want to add friction. And look at that. Now we start getting thermal energy into the system. That means that the wheels are heating up the track or vice versa. And you can see that we're going lower and lower because our total energy is being used up by the thermal as well. Okay, I want you to practice that for a while. Go through the Google Classroom or the Google form that is posted on Classroom for your asynchronous. Watch the videos, get comfortable with that, answer the questions, and then we're going to talk about this in class. Ladies and gentlemen, I hope you're excited about doing a Rube Goldberg machine. We should have a whole lot of fun with this. All right, and we will see you in class.